Hi, everybody. We are going to look at some more scatter plots today. But what we're going to do is we're actually going to answer some questions based on those scatter plots by coming up with a formula for a line that best represents that scatter plot. So in the previous lesson, we talked about how you can categorize a scatter plot as being linear. And so we're going to look at scatter plots today that take on that linear shape, and we're going to come up with something called a line of best fit. And what this is it's basically a line that we can use to do some predictions of our data. Okay, so if you look at the example I have here, this is comparing the total amount of fat with the total amount of calories in fast food. And so our job is to come up with an equation that we think best represents this data. Now, it's not going to be perfect because our scatter plot does not show a perfect line. But the line that we do write the equation of, we can use to make some predictions. So what I mean by that is I could say, okay, if I have some fast food that contains 50 grams of fat, using my line, how many total calories could I expect that item to have? And so it's just a way to make predictions of your data. Okay, so this is a really good review of writing equations of lines, which we spent a really long time doing. So it's really nothing new. It's steps that you've done before. It's just using a scatter plot instead of actual points on a line. Okay, so you can see up here I have the 3 steps that we're going to follow. And this is just from what you remember, hopefully, about writing the equation of a line when you're given 2 points. First, you find the slope. And so to do that, we have to use our slope formula. So I'm just going to write it here so we can all remember what that looks like. And then after we have the slope, we pick one point to plug in to y equals mx plus b to figure out our y-intercept. And then once you know your y-intercept, you actually write the equation of the line by putting in the m and the b, the slope and the y-intercept. Okay, so kind of 3 steps for each one of these. All right, so let's look at that fast food example. So the hard part about lines of best fit is that we could all choose a different line to represent our data, and it would be okay. You will never be able to get the perfect line of best fit unless you were to use a graphing calculator. So next year in algebra, you guys will learn how to do this on your calculator so that you're all going to get the same exact line of best fit. But for now, because we're doing this by hand, we just kind of have to go with whatever we think is best. Okay, so when I say that, I want you to look at your scatter plot and I want you to try and find a line that goes through the center of your scatter plot and hits as many points as possible. Okay, now you guys at home might have a ruler that you have because you've printed out these notes. Because I'm doing this on my computer screen, I'm going to try and make this be as best I can. So I'm looking at drawing my line, let's see, right through these points. Okay, so I'm just going to darken in the ones I went through. So I'm saying my line looks like it goes through, let's say, these 4 points. Okay, so the reason I chose to draw my line there is because I was thinking in my head, okay, that kind of goes, in the middle of my scatter plot, and I've hit 4 points, even 5 if you count that one that's right here. And so I think that's a pretty good line of best fit. Now, some of you might have chosen to go like this with your line for the same reason. Maybe you thought that was more towards the center. and it still hits 4 points. So that's what I'm saying about how we could all have different equations here, okay? But for the purpose of learning this for the first time, let's all choose the line that I drew, just so that you can see how I'm going to work through this, okay? So based on the line I drew, I need to pick 2 points from that line and find the slope, okay? So I'm just going to choose this first point here, and I know that I can't see what it is, but if I go on my table, I can see that it's this point right here, 5, 300. So I'm just going to rewrite that up here. And then my next point I'm going to pick, well, I'll circle them. So I'm using this one, and then I'll use this one. So that one, if I look at my table, must be 25, 500. 25. Okay, and again, I'm just picking a random 2 points that are on the line that I drew. Okay, so that's important. The points you pick have to be on the line that you drew. So I could have picked the other 2 or other 3 that my line went through. I'm just choosing these ones. Okay? All right, so step 1 is to find our slope. So remember, this is x1, y1, this is x2, y2. So to find our slope, we do y2 minus y1, 500 minus 300, over x2 minus x1, 25 minus 5. Okay, so 500 minus 300 is 200 over 20, which comes out to be 10. Okay, so we've completed step 1. We've found the slope of the line that we're trying to get our equation of. My next step is to figure out what my y-intercept would be. Okay, so I'm going to, again, just pick one of those points that are on your line. I'll just go with the first one. So in that case, my y is 300. My slope I just got was 10. The x-coordinate from the point I'm using is 5. And b is what I don't know. Okay, so if I go through and I simplify this, to solve for b, I'm going to subtract 50 from both sides. And I get that my y-intercept is 250. Now, if you look at my line that I drew, it kind of looks like it would be 250, doesn't it? It's going to kind of go right under that 260 there, so it makes sense. So my last step is just to put this all together. So the equation of my line of best fit would be y equals 10x plus 250. Okay, so we're not going to do anything with it just yet, but down the road, we'll be using that equation to figure out some predictions, like I was saying before. Okay? All right, so let's look at example 2. This is the predicted annual cost to raise a child from birth to adulthood. So we have the child's age versus the annual cost, meaning like how much per year does it cost the parent. Okay, so part A says to make a scatter plot. So this is what we did in the previous lesson. Thankfully, our axes and our scales have already been done for us, so we can go ahead and just start plotting these points. So take a second and do that, and you're going to have to do some approximating because they're not perfect. Okay, so pretty simple scatter plot, not a ton of points to look at. And so we want to figure out where would be my line of best fit. Where can I draw a line that looks like it goes kind of through the center of my data? Okay, and again, what you see might be different from what I see, what might be different from someone in your class sees. So I am going to choose, I'm going to try and connect those 3. I feel like that works out well. Okay, and depending on, remember we were estimating where these points went. So depending on where you plotted them, maybe those points don't line up as well as they do for me, in which case you would, draw a different line. So, but again, because we're learning, if you guys could try and use the points that I did, I think that would help. Okay, so we're going to write an equation for the line that we just drew, the line of best fit. And so looking at my table here, I'm going to try and use some nice points. I'm going to pick this one here. What is that? 11,700. And then I think I'm going to go with this last one, which was 16,700. Okay, again, you can pick any 2 points that are on your line. It does not have to be the ones that I picked. Okay, so your next step is to do your slope formula. So again, that's y2 minus y1 all over x2 minus x1. Okay, so looking at the difference in my y's, that looks like it's going to be 5,000 over 9. So one thing that you guys will start to notice is that these equations do not always come out to be nice. Okay, we actually got pretty lucky in example one that our slope and y-intercept came out to be so nice, because this one is not. So one thing that I am totally fine with you doing is leaving these numbers as fractions, okay? Remember, with slope, a lot of times we leave them as fractions anyway, so I would not go and divide 5,000 by 9 and put 555.5 repeating. I would honestly leave it 5,000 over 9 because we're used to seeing the slope as an improper fraction. Okay, so we've done step one. We found the slope. Now let's go ahead and find the y-intercept. So again, we just pick one of the points that we have on our line. I'll just use that first one again. So I'm plugging it into, I'm going to do my work over here. Y equals mx plus b. So if I'm using that first point, my y is 11,700. I just got 5,000 over 9 for my slope times my x coordinate of that point is 6, and b is what I don't know. Okay, so we have to figure out what the slope times my x coordinate is. So let's see. I am going to be getting a repeating decimal, so I'm going to try and leave this as a fraction. I'm going to do 5,000 times 6, which is 30,000 over 9. Okay, so then what we have to do is subtract 11,700 minus this 30,000 over 9. Now, I will simplify that for you guys because I know typing that into your calculator might be kind of strange. So this is 3,333.3 repeating, or a third. So if you're using your scientific calculators at home, the way that you can solve for B is you can type in 11,700 minus 333, and then use your ABC key to type in the 1/3. Oops, I left off a 3 there. Okay, so using that fraction key on your calculator, let's see here. I wish I had my scientific calculator at home. I do not. I'm a little worried about what I'm going to get here. Let's see. Okay, good. That worked. So I'm getting 8,366 and 2/3. Okay, or if you were getting 0.6 repeating, same thing. Okay, so See what I mean? They're not always going to be nice numbers. So I'm going to put this back in to write the equation of my line of best fit. This lovely equation right here. And so what we're going to do in part C is we're going to use that equation to predict how much it's going to cost to raise a child who is 10 years old. Okay, so this is what I was talking about, using your equation to make predictions. So if you look, age is on the x-axis. And since we know the age is 10, we're going to take that number and plug it in for x in our equation. Okay, so I'm going to take the equation I just wrote, and I am going to replace x with 10. All right, so give you a second to type that in. Okay, so I am getting 13,922, and remember this is money, so I'm going to round it to 22 cents. Okay, so let's talk about if that number makes sense. If I go back up to my table, the data shows that for a 9-year-old child, it costs $12,600 per year. And for a 12-year-old child, it costs $15,000 per year. We just found the cost for a 10-year-old child, which is in between those two, and my answer that I got is in between those two. So that's a good sign. That means that we are definitely on the right track here. Okay. One thing that kids usually ask me is, if this was a test, and I chose different points, how would I be graded on that? So with these kinds of questions, there's always going to be some kind of, like leeway. Okay, you're not always going to have the exact answer that I do. As long as I can see your work and your work is correct based off your line that you drew, you'll get it right. Okay, so it's very frustrating for teachers to grade these because potentially we could have quite a few different equations and answers, but that's how it is. So you don't have to worry about that. All right, we have a couple more here. So example 3 says the weight of an alligator at various times during a feeding trial. So that's what we're looking at in the table here. So we have weeks versus the weight in pounds. So the first thing we have to do is make a scatter plot. Okay, so we talked about this the other day. So we're going to label weeks on our x-axis, and we're going to label weight on our y-axis. Okay, so we have to go basically from 0 to 49. So what do we got here? 1, 2, 3. So we have 10 boxes. So we're going to have to do, this is 0. Should work out if I'm counting by 5s. There we go. And then our weight has to go from 0 to, let's say, 20. And so if this is also 10, 1, 2, 3, 4, 5. Yep, we can count by 2s. Okay, so once you have your scales, we can go ahead and plot our points. I do here? 18 is 10, 27. Okay. It's tricky when you are trying to figure out where all these decimals go, but I think that looks good. All right, so let's see here. Where can we draw our line of best fit? Again, to hit as many points as we can, but also to kind of go through the middle of our data. All right, I think, I'm wondering if I try, let me think. I'm going to try and hit those 3 points. Not a perfectly straight line, but I think it'll work. Okay, so I'm going to write for my equation, I'm going to use that first point, 0, 6, so this one here. And then anything else look good? What's this one? 34, 15. Or I don't want to use 9, 8.6. I'm going to stay away from the decimals. So I'll use the 34 and the 15. Not that it would be wrong if I used the decimal. I just, sometimes it's easier to stay away. Okay, so let's go ahead and find our slope. So 15 minus 6 is y2 minus y1. 34 minus 0. So 9/34. Lovely. That is a really awesome slope. Now, here's a good thing. Because I had my line go right through 0, 6, I technically don't need to do any work here because I'm saying that my y-intercept is 6. So that's kind of cool. Okay, I'm choosing to use that point. If I didn't use 0, 6, I have to do the y equals mx plus b, plug in a point, solve for b. Okay, so we know our equation of our line is y equals 9/34 x plus 6. All right, so now we're going to use it to do some predictions. So predict the weight of this alligator at week 52 using your line of best fit. Okay, so weeks are our x values. Okay, so if I'm looking for 52 weeks, I am putting in 52 for x. So y equals 9/34 times 52 plus 6. Okay, so let's figure out what that gives us. 9/34, remember you can use your ABC key, 9 ABC 34 times 52 plus 6. Okay, so I am getting a long decimal. I'm getting 19.7647 ... It doesn't say anything about rounding, so I'm going to just go to the nearest tenth since that seems to be what the weights in the table we're going by. So when I write my final answer, I'm going to say 19.8 pounds. Okay. And interestingly enough, if you look, I'm just looking to see, does that make sense? So what's very interesting about this is on the scatter plot at week 49, it says that the weight of the alligator is 19.8 pounds. But remember, because our line didn't go through that point, our estimation or our prediction is a little bit off. Okay, so that can happen, but it's so close, 49 weeks and 52 weeks. I mean, that's 3 weeks apart. So it's so close that it is okay. So I'm glad that happened so you guys could see that. All right, let's see. I think we have one more. Yep, last one. Example 4. The scatter plot shows the number of cell phone subscribers in the United States. Write an equation in slope-intercept form for the line of best fit that is drawn and interpret the slope and y-intercept. Okay, so first things first, when it says written in slope-intercept form, remember all that means is y equals mx plus b, so that's what we've been doing. All right, so let's look at the graph. We have years since 1999 versus the number of subscribers in millions. Okay, and the line of best fit has been drawn in for us, so that's pretty awesome. It looks like the line is going through 3 points, maybe 4 if you want to count that one. So I would probably recommend using ones that we can tell exactly what they are. So I'm thinking maybe these two. I kind of like those. Okay, again, you could have chosen any of the other ones, but I'm going to go with those two. So I'm going to use 7 to 25 as my first point, and then I'm going to use 8 to 50. I know it looks like it's a little bit above 250, but we'll go with that. Okay, so again, this is all about estimating. So my slope is going to be 250 minus 225 over 8 minus 7. Ooh, this works out very nice. 25 over 1 is 25. Okay, so now I'm going to do y equals mx plus b. And I'll choose the first point to plug in. So I'm going to do 225 for my y, 25 for my slope, 7 for my x, plus b. And so then I know that 25 times 7 is going to be 175. 175 plus b, which then if I subtract 175 from both sides is going to give me 50. Okay, so we have our equation equaling y equals 25x plus 50. Okay, so we've done the first part of the question. We've written the equation in slope-intercept form for the line of best fit. Now it says to interpret the slope and the y-intercept. So we did this way back when you had to tell me what the slope represented in the context of the problem. So what does the 25 represent in this situation? So remember, slope is the same as rate of change. And rate of change means the change in y over the change in x. So in this situation, it means the number of subscribers per year. Okay, so that's what we're dealing with here. So let's say for the slope, it represents, and let's use the number. So it represents that there are 25, because that was our slope, 25 million, because it's in millions, subscribers. Let me back that up. I'm going to say cell phone subscribers. 25 million cell phone it represents that there are 25 million cell phone subscribers that sign up per year. So that's the key, is it's a rate. Okay, so it's how many cell phone subscribers per year. Okay, and then the y-intercept. So I want you to notice that it's saying years since 1999. Okay, so in year 0, that is actually 1999. So when we're looking at 50 for our y-intercept, it means that in 1999, there were 50 million subscribers. Okay, because that's like our starting point. So we're going to say in 1999, there were 50 million cell phone subscribers. And again, looking at the scatter plot, you can see, you know, it's not right on 50, okay, but it's not perfect, okay? It's a line of best fit, so what's the best that we can get based on this? Now, the thing I don't love about this question, to be honest, is that because we are writing the equation of this line, it really should look closer to 50. But what this probably means is that those points that we chose, because we didn't know the exact coordinates, they're probably off a little bit, which made it look like our y-intercept was off a little bit. Okay, so normally, like I did in the first 3 examples, I would give you a table so that you wouldn't have to guess what those coordinates were. Okay, so that's why it looks a little bit off. All right, so we're going to practice this again in the next lesson. Good job.